For more than a century, Detroit controlled what mattered most underneath the car. Not just the badge, not just the engine, not just the body shape that Americans saw in the driveway. The real power was deeper. The frame, the chassis, the crash structure, the drivetrain, the suspension, the manufacturing system, the industrial skeleton that made Ford, GM, and Chrysler more than car brands. It made them platform empires. But now that empire is being challenged from a place most Americans still think of as just a battery supplier. CATL is no longer trying to sell only cells. With the Bedrock Chassis, it is moving toward the floor of the electric vehicle itself, a battery-centric foundation that can integrate the pack electric drive system, thermal management, and chassis control into one ready-made lower body. And that is why the image matters. Picture a TOG T10X above the platform with CATL's Bedrock Chassis beneath it. This is not a review of a Turkish SUV. This is a warning about who may control the next generation of EV architecture. The threat is not that CATL wants to sell more batteries. The threat is that CATL wants to sell the floor, the spine, and the nervous system of the electric car. To understand why this matters, you have to understand what Detroit actually built. Detroit did not become Detroit because it could design a pretty hood or attach a famous badge to a grill. Detroit became the center of American automotive power because it mastered the platform, the invisible system underneath the vehicle that determines strength, durability, cost repairability, crash behavior, and manufacturing scale. The Ford F-Series is not just a truck. It is a complete industrial machine. Frame, suspension, drivetrain, towing, hardware, service network parts, supply, dealer infrastructure, and decades of customer trust all work together. That is why the F-150 became more than transportation. It became a business tool, a farm tool, a family vehicle, and in many parts of America, a symbol of competence. GM built its power the same way. Chevrolet and GM C-Trucks were not just products. They were platform strategies. One engineering foundation could support different bodies, different price points, different trims, and different buyers. Stellantis did the same with Ram and Jeep, turning body-on-frame durability and off-road identity into industrial advantages. Then the EV era arrived, and Detroit believed the same logic would continue. GM built Ultium. Ford electrified the F-150. Tesla proved the skateboard platform could scale globally. The assumption was simple. The automaker still controls the deep architecture. The supplier provides parts, but the automaker owns the foundation. CATL's Bedrock Chassis challenges that assumption, because this is not just a battery pack. It is an attempt to turn the lower body of the EV into a supplier-built industrial product. Battery structure, thermal management, electric drive, and chassis control begin to merge into one platform layer. That changes the question. The old question was, which automaker builds the best EV? The new question is more dangerous: what happens when the most important part of the EV can be bought from someone else? If the platform becomes a supplier product, then the automaker loses the deepest layer of control. The first thing CATL's Bedrock Chassis changes is the center of the vehicle itself. In a traditional electric vehicle, the battery is often treated as a large pack placed into the floor. It is heavy, expensive, structurally important, but still understood as one major component inside a larger car. CATL's battery-centric approach flips that logic. The battery is no longer just cargo under the cabin. It becomes part of the vehicle's structural foundation. That is the meaning of cell-to-chassis integration. Instead of building a car and then installing a battery, the vehicle is designed around the battery from the beginning. The pack, the floor, the crash structure, the cooling system, and the mounting points begin to behave like one integrated skeleton. For an American truck buyer, that sounds abstract, but the impact is very real: lower center of gravity, potentially better packaging, fewer duplicated structures, and more control over how force moves through the vehicle during stress. This is not a battery inside a car. This is a car built around the battery. The second change is more political than it looks. Crash safety becomes a supplier weapon. For decades, safety belonged to the automaker's identity. Volvo built trust around it. Mercedes engineered prestige around it. Ford and GM earned loyalty by convincing families and workers that their vehicles could survive real American roads. Safety was not just regulation, it was emotional ownership. But when CATL promotes Bedrock as a chassis designed around battery safety and crash resistance, it steps into that sacred territory. It is no longer saying our cells have good chemistry. It is saying our platform can protect the energy system when the vehicle is under violent physical stress. That matters because electric vehicles carry a different kind of fear. Gasoline vehicles burn, but battery fires have a unique psychological weight. Americans worry about thermal runaway, emergency response repair cost, and what happens when thousands of pounds of EV mass meet highway speed. If a battery supplier can persuade automakers and regulators that its integrated chassis is safe, then it starts selling more than hardware. It starts selling trust. The third change is the most dangerous for Detroit, the separation of upper body and lower body. In the old model, a serious automaker had to master almost everything. You needed the platform, the crash structure, the battery pack, the electric drive units, the cooling system, the brake system, the suspension layout, the chassis controller, and the production engineering. That requirement protected legacy automakers because the barrier to entry was enormous. Bedrock attacks that barrier. A new EV brand could focus on the upper body design cabin screens, software experience, brand positioning, and customer interface, while relying on a supplier-built lower body for the hardest mechanical and electrical foundation. That does not mean building cars becomes easy, but it means the deepest engineering burden can be compressed, packaged, and transferred. That is why TOG is such a useful image for this story. The TOG T10X gives the viewer a face in SUV, a brand, a product people can understand. But the real character is below it, the chassis layer that suggests a future where a company can build a vehicle identity on top of someone else's electric skeleton. In the EV age, the company that controls the lower body may control the real value of the vehicle. The fourth change is speed. In the auto industry, development time is not just a calendar problem. It is capital. It is engineering manpower. It is crash testing, supplier coordination, factory planning, software integration, validation, and warranty risk. A 3-year vehicle cycle can consume billions before the first customer takes delivery. So if a supplier platform can shorten that cycle, the threat is not only technical, it is financial. Detroit may still build better trucks. Ford may still understand American towing better than almost anyone. GM may still have enormous manufacturing depth. Stellantis may still understand body-on-frame toughness and off-road identity. None of that disappears overnight. But if new competitors can build acceptable EVs faster, cheaper, and with less engineering burden, the platform war changes completely. The enemy is not just a better car. The enemy is a faster industrial clock. Now place this against the American benchmarks. Start with the Ford F-150 Lightning. Ford is not weak in trucks. That would be the wrong lesson. Ford understands the American pickup buyer better than almost anyone on earth. The company knows towing job sites, fleet buyers, rural service dealer support, and the emotional weight of the F-Series badge. But the F-150 Lightning still represents the traditional automaker model. Ford controls the vehicle. Ford controls the platform. Ford carries the capital burden. And Ford absorbs the risk if American buyers decide the electric truck does not fit their daily reality. That is a powerful model, but it is also heavy, expensive, and slow to change. Then look at Chevrolet Silverado EV and GM's Ultium strategy. Ultium was designed as an internal empire, a flexible battery, an EV architecture meant to power everything from crossovers to large electric trucks. On paper, that makes sense. GM wants control. GM wants scale. GM wants a common foundation across its electric future. But Bedrock raises a brutal question. What happens if a supplier-built platform becomes good enough? If an outside platform can deliver the lower body battery structure, thermal management, electric drive integration, and chassis control, then an internal platform is no longer automatically a moat. It can become a cost burden. It can become a slow-moving capital machine, competing against a modular system that other brands can adopt faster. Ram shows another side of the problem. The American pickup market does not reward theory. It rewards confidence. A truck buyer wants to know what happens in Michigan winter on a Texas highway, with a trailer behind the vehicle and with a family inside the cabin. Range numbers alone are not enough. The truck has to feel dependable when the road is ugly, the load is heavy, and the charging station is not conveniently nearby. That is why any integrated EV foundation matters. If a supplier platform can reduce engineering complexity and give new brands a credible base for SUV or truck-like vehicles, then Detroit is no longer fighting only brand versus brand. It is fighting one industrial model against another. And then there is Tesla. Tesla proved that the skateboard platform could scale. The Model Y became a global EV benchmark because Tesla understood packaging, manufacturing simplification, software control, and electric efficiency better than the old industry expected. But CATL is pushing the idea into a different lane. Tesla uses its platform to build Tesla vehicles. CATL wants to turn the platform itself into an exportable industrial weapon. That is the strategic difference. Detroit can compete with a vehicle. Detroit can benchmark a motor, a battery pack, a screen, or a charging curve. But competing against a supplier-controlled EV foundation is different because the threat can appear under many bodies, many badges, and many markets at once. The badge may change. The skeleton may not. The economic danger begins with a simple reversal. In the old auto industry, suppliers served the automaker. They provided seats, wiring, tires, sensors, transmissions, electronics, and thousands of specialized parts. But the automaker remained the architect. Ford decided what the truck was. GM decided what the platform would become. Stellantis decided how the vehicle would feel, work, and survive. In the EV industry, that hierarchy is starting to bend. If CATL controls the battery, the chassis structure, the thermal system, the electric drive integration, and the chassis controller, then CATL is no longer just a supplier. It becomes the keeper of the deepest value layer. That is the power shift Detroit has to watch. The second impact is the collapse of the old entry barrier. For decades, building a real car company required enormous industrial depth. You needed engineers, factories, suppliers, crash testing, validation service networks, and enough capital to survive years before profit arrived. That barrier protected legacy automakers because very few outsiders could cross it. But a ready-made EV foundation changes the math. A new brand does not have to master every layer at once. It can buy or co-develop the lower body, then spend its resources on design, cabin experience, software pricing, and market positioning. That is why the TOG image is important. It shows a future where a newer national brand can stand on top of an industrial foundation supplied by a battery giant. Detroit's moat does not disappear, but it gets narrower. The third impact is capital pressure. Ford, GM, and Stellantis are not just building EVs. They are funding battery plants, software divisions, dealer transitions, labor agreements, factory conversions, charging partnerships, and new platform programs at the same time. Every delay costs money. Every wrong platform bet becomes a balance sheet wound. Every slowdown in EV demand forces management to defend spending that may not pay back quickly. Now imagine competing against brands that do not carry the same full-stack burden. They may not have Detroit's heritage. They may not have America's truck credibility. But if they can reach market faster using supplier-built platforms, they can pressure price speed and investor expectations at the same time. That is not a product threat. That is a business model threat. Then comes the geopolitical problem. The issue is not nationality. The issue is dependency. If the lower body of the EV battery structure, thermal system, drive integration, and control architecture comes from a foreign supplier, Washington will eventually ask hard questions. What happens to tariffs? What happens to data? What happens to safety standards? What happens if the chassis, controller, battery management system, and vehicle foundation are tied to an overseas industrial ecosystem? And if that technology enters through Turkey, Europe, Mexico licensing deals or third-party brands, the question becomes even harder. America may think it is blocking foreign cars, but what if the foreign platform arrives underneath a different badge? That is why CATL Bedrock matters. It is not just a chassis. It is a test of who controls the industrial foundation of the EV age. Now imagine, the year is 2027. A new EV brand appears in Europe, the Middle East, or Southeast Asia. It does not arrive with a century of manufacturing history. It does not have Ford's truck legacy, GM's industrial footprint, or Tesla's software mythology. But it does not need to build everything from zero. It starts with a supplier-built electric foundation. Battery structure, thermal management, electric drive, integration, chassis control, and lower body architecture are already packaged into one platform layer. Then the brand places an SUV body above it, something that looks familiar, modern, and easy to understand. Think of the TOG T10X as the visual symbol. The customer sees a clean electric SUV, but the real industrial story is hidden underneath the floor. The cabin gets large screens. The software feels modern enough. The price is aggressive. The range is acceptable. The vehicle may not be revolutionary on the surface, but that is exactly the point. It does not need to shock the world. It only needs to be good enough, fast enough, and cheap enough to pressure legacy automakers that are still spending billions to control every layer themselves. To the consumer, it is just another EV. To the investor, it is another new brand. But to Detroit, it should look like something far more serious, a nearly complete EV supply chain compressed into a ready-made vehicle foundation. And if that foundation enters new markets through licensing, joint ventures, regional assembly, or a different badge, then America faces a harder question. Is it competing against a car company? Or is it competing against a package industrial system? Detroit does not have to fear the TOG T10X. That would be too simple. A single SUV is not the real threat. A single new brand is not the real threat. Even one supplier partnership is not enough to overturn a century of American automotive power. The real threat is the model behind it. For generations, Detroit controlled what lived underneath the vehicle. The frame, the platform, the crash structure, the drivetrain, the factory logic. That was the real empire. Not the screen, not the badge, not the marketing language about the future. The empire was under the floor. CATL's Bedrock Chassis challenges that empire at its deepest layer. If a battery supplier can sell the battery, the chassis, the drivetrain integration, the thermal system, and the control architecture as one foundation, then the line between automaker and supplier begins to blur. The company that owns the upper body may own the shape, but the company that owns the lower body may own the value. That is why this matters to Ford, GM, Stellantis, Tesla investors, workers, and anyone watching the next phase of the EV war. Detroit is not facing a Turkish SUV. Detroit is facing a future where the hardest part of the electric vehicle can be bought, shipped, localized, and scaled before legacy automakers finish their next platform cycle. The next automotive war may not begin in the showroom. It may begin underneath the floor,